Okay, so this is the lesson on how to multiply radicals, page 9 in your booklets. So when we're multiplying radicals, there's 3 steps you have to follow. So number 1 is you multiply the coefficients, so the numbers underneath the radicals, and then you multiply the number in front of the radicals, and then you simplify. So in example 1, we have the square root of 3 times the square root of 5. So we would say this is the square root of 3 times 5. They get combined under the radical, so it's the square root of 15. Pretty straightforward. Same with the square root of 7 times 7 would be the square root of 49, or we can see that it's the square root of 7 times 7. There's 2 of them, so this equals 7. Remember, if they're the same root times each other, then it's just the number underneath. Square root of 6 times 8 would be the square root of 48. And example D is where we have to apply step 1 and step 2. So step 1 is multiply the coefficients together. So the coefficients would be the numbers in front, the constants in front. So 3 times 2 is 6. And then we multiply what's in the radicand together. So 10 times 15. So this would be 6 square root 150. So that's how we multiply radicals when they're just 2 radicals multiplying. However, and if you watched our review video on how to multiply binomials, trinomials, etc., you'll notice in example 2 that we have one term, a monomial, multiplied by 2 terms. So we need to distribute. So we're going to take this 2 square root 2, and we are going to multiply each term by 2 root 2. So 2 times 3 would be 6. And you know what? Let's back up. Let's write this out. So 2 square root 2 times 3 square root 6 is the first one. And then we have 2 square root 2 times negative square root 3. Those are the 2 pieces we have to multiply. So 2 square root 2 times 3 square root 6 would be 2 times 3, which is 6. Square root 2 times square root 6 would be square root 12. The second piece would be 2 times negative 1, so negative 2. And 2 times 3 would be square root 6. So we can say that 2 root 2 times 3 square root 6 minus root 3 equals 6 square root 12, take away 2 square root 6. Now notice in this question it says simplify if possible. So make sure when you're done multiplying your radicals, you check and see if the number underneath the radical can be simplified further, and if you can combine radicals at all. Now 12 and 6 are not like radicals, we cannot put them together, but root 12 we can actually break apart. We can say this is 6 times the square root of 4 times 3, which equals 6 times 2 square root 3. Remember, the square root of 4 we can evaluate and get 2. And the second one remains the same. So our final answer would be 12 square root 3 minus 2 square root 6. Okay, so pause the video for a moment and just write that down and check it out and make sure you understand. So now let's do ones where we have to FOIL. Okay, so in this case it might be helpful to write out the letters to begin with, just because there's a lot happening in this question. So for FOIL, the reason we're FOILing is because we have a binomial times a binomial. So FOIL, remember F stands for first, so the first term in the first bracket times the first term in the second bracket. So 3 square root 2 times 4 square root 2 would be 12 square root 4. We can simplify this though, because the square root of 4 is 2. So it would be 12 times 2, which equals 24. Okay, so again, we multiplied the first 2 terms of each bracket, multiplied the coefficients to get 12, multiplied the radicands to get 4, evaluated the square root of 4 to get 2, and 12 times 2 equals 24. All right, now let's do the outside of each bracket. So we have 3 square root 2 times negative 3 square root 5. So 3 times negative 3 is negative 9. 2 times 5 is square root 10, and we can't simplify that any further. The insides, we have 4 square root 5 times 4 square root 2, which is equal to 16 square root 10. Notice these are the same, so we're probably going to combine them at the end. And then finally the last term in each bracket, 4 square root 5 times negative 3 square root 5. Well, 4 times negative 3 is negative 12. And square root 5 times square root 5 is 5. So our answer is negative 60. Okay, and so our final answer, make sure you are very clear about where your final answer is. We would say, therefore, 3 square root 2 minus 4 square root 5 times 4 square root 2 minus 3 root 5 equals 24 plus negative 60, which is negative 36, and negative 9 plus 16 root 10, which would be 7 square root 10. So 7 square root 10 take away 36. Make sure you always combine like terms at the end. For B, remember when we're squaring a binomial, we have to multiply it by itself. So 2 square root 7 plus square root 3 times 2 square root 7 plus square root 3. Okay, and again, let's do FOIL. So we have the first term times the first term. So 2 root 7 times 2 root 7. Notice that I'm using a dot for my multiplication, and that's because eventually we'll be using variables in our radicals, and so we don't want to use an x just in case it confuses which is a variable and which is a multiplication. So 2 times 2 is 4. Root 7 times root 7 is the square root of 49, but we know the square root of 49 is 7. Alright, so now the outside. So the outside of the first one times the outside of the second one. So we have 2 square root 21. And I don't think we can simplify square root 21 because there's no perfect squares that multiply to it. So we'll leave it as is. Then we do the inside, square root 3 times 2 square root 7, and we've already done this in the previous step, so it's 2 square root 21. And finally we have root 3 times root 3, which equals 3. Square root of 9, which equals 3. So we'd say our final answer, 2 root 7 plus square root 3, this means therefore, squared equals 28 plus 3, which is 31, and 2 plus 2 is 4 square root 21 plus 31. And that is our final answer, 21. Okay. Now, notice C and D both have a star, so we know something special. But notice they're exactly the same, square root 6, square root 2, square root 6, square root 2. But the only thing that's different is the operation in the middle, plus, minus. When that happens, we call this a difference of squares. So we had a difference of squares and we FOILed it out. We factored it, and now we're going to get something special when we multiply it out again. So let's go ahead and do that, and then I'll show you how we could have skipped all of these steps. So the first one is square root 6 times the second one is square root 6, which is 6. The outsides are square root 6 times negative root 2, which is negative square root 12. The insides are square root 2 times positive square root 6, which is positive square root 12. Notice what's happening here. And the last is square root 2 times negative square root 2, which is negative 2. So our answer is 6 take away 2, which is 4. And then what happens in the middle is we have negative root 12 plus root 12. So these cancel out. So when you have a difference of squares, or when you have two binomials multiplying with opposite operations, opposite signs we'll say, but same terms, it is a difference of squares. Okay. So the middle terms will always cancel out. So when you have two binomials that are multiplying with opposite signs but the same terms, it's a difference of squares. So it cancels out the entire middle term. So if we look at D, we have the exact same terms, just one is subtracting, one is adding. So we could FOIL, or we could realize that the entire middles cancel out, and all we have to multiply is the first and the last. So the first would be 4 square root 25, and the last would be negative square root 64. And we can simplify this further to 4 times 5 minus 8, and 20 take away 8 is 12. So if you ever notice that it's the same binomial with an opposite term multiplying, you can skip the middles and just do the first and last.